Okay, it's almost 1 in the morning. Here's my chapter 16 homework. Using my formulas. Anyways, this concept of moment about a point, whichever one you want. Your mass times your acceleration times the distance, perpendicular distance from the vector. Your moment of inertia of your original times your angular acceleration. Most of the time this is 0. So, in the first couple problems. Okay, no angular acceleration because it's kept rigid. All the motion is this direction, but there are some vertical forces, so you just have to solve first. Hey, let's figure out what our acceleration is going to be so that we can use this little cheat method. So your mass times your accelerations times your distance from your centroid, basically. Your AY plus your BY is going to equal 24.525 newtons because that's the weight of your little thing. So you take this and you times it, and this is just the simple way to figure out your distance over here. So one side is going to be your typical, you find your moment about point B, and then the right side is going to be what you set it equal to, which is the little formula, I sub g, your moment of inertia times your angular acceleration, which we don't have, times your mass times your acceleration, times the distance from whatever point of reference you're changing it from, which would be from here to here. Okay, so 24.5, blah, 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 AY. Then this goes to 0. This is 22.5, blah, 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 blah. You get AY 3.819, and this BY is 20.706. Now in the solutions manual, they have something different, which I don't really follow because somehow they replace their radius from, which is 0.3, and they go and replace it with 1. They go from 2 times r divided by pi to 2 times r divided by pi, which the only way they can get that is if they say r is 1, which doesn't make sense with what we were given. We were given that r is 0.3, so that's why my numbers are different than what these guys got. Oh, actually, I've got the same numbers. Oh, never mind. Well, I don't know what they did to get r as 1 other than maybe they just said, okay, all the r values are the same, so instead of crossing them out, we're just going to make them 1s. Well, that still doesn't make over sense because over here they are. I don't know what they did in there because whatever. So this problem is really just playing with angles a whole lot. Force, blah, 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 the acceleration of the rod. So A normal and A tangential, V squared over R, you get 12.5 if you convert it from inches, blah, 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 12.5. Feet per second squared, that's at this direction, normal. A tangential is mg cosine 30, m times A tangential. Oh, excuse me, now you're gonna hear that, sorry. You get 27.886. I didn't show that step. Anyways, our mass is given in, or I mean our force is given in pounds, so this really becomes 16, and this is the mass you derive. I tried to do this with sine first. I don't know if you can see, but I've erased stuff, and it gave me the wrong value, so I just resorted to going back to what they did on the solutions manual. Anyways, beta is tangent inverse. This just gives you the angle. So, of my tangential. What the a squared equals blah, 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 30.56. We already have a tangential and we have a normal, so it's not that hard to get, but mass times acceleration, 30.56, 15.15185 pounds, whatever. Taking too long to explain stuff. This one's this, 6 kilograms, 360 RPM, so you gotta convert these things, but you find your moment of inertia values, then you find your friction force, acceleration in this direction radially is 10.227, so angular acceleration I should say. So this one, angular acceleration is 33.33. And you calculate your time, then you use your time to figure out what your speed is, and what your speed is there. This one's the simplest problem, I think, to do of the batch, because you plug it into a formula. This is your forces here, this is your weight times your total, well, this is your weight, this is the force. So 5A equals 10.95, A equals 2.19 meters per second squared, 10.95 radians per second squared is your angular acceleration. Which I thought was given, but I don't see it right here. It's up here. You put this back in here, and then you get the 10 point. I wrote this wrong. That's what happened. This is. This is really bad. Okay. 40 times this. This is you're taking your moments, so you do it about this point, but then you got k squared. And k squared equals that. Generation rate of stars. You got all this, Cx, Cy, reactions, alpha, rotation. This one is probably the easiest, another easier one to do. This equals this and this equals this. So you take your weight sine beta times r. You can simplify this down, get rid of your masses. Rg sine beta equals r squared plus k squared times alpha. Alpha equals this divided by this. So accelerate, I shouldn't say alpha. Well, it is alpha, but angular acceleration equals that. And so acceleration equals radius times your angular acceleration. So acceleration is really r squared g sine beta divided by r squared plus k squared. Then we can get to these. I really don't know what to say other than obviously you gotta get them in feet. There's a feet per second squared. Now you've got your mass times your acceleration times your radius time plus your I over alpha, which is 1.667, blah 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 blah. And then you solve for alpha. Now alpha, well, acceleration is radius times your alpha, so you found that. Force times mass times acceleration. Well, now we know what our mass is and we know what our acceleration is, so now we know what our force is. And now, since we've got newtons plus blah blah blah, or sorry, not newtons, and where's this? or normal force. Times 5, 1.25. Force is, it is not static, so it's slipping, or well, it's moving. Blah, blah, blah. Okay, let's read this. It slides. Because it's sliding because our 1.6 pounds exceeds that, so we know it's going to slide. Anyways. Then you find your alpha for that one and find your acceleration here. What? It doesn't make sense. Oh yeah, it does. We're finding one for the inner versus the outer. And follow the same sort of thing, but with C. And then you do the same thing, but for D. Oh my gosh. Your accelerations are going to be the same because they've got the same radius. So you find the acceleration with one to the other. This is an equal sign. You relate the two equations together. You plug them in together, and then you get angular acceleration is 21.97. And that's just in meters per second is your speed going this way. And your D is your reaction force. Is 11.87 at D. Yeah. You have to find this to be able to find this, and then, just like everything in math, everything ties in with the other thing. So don't ever mess up. Anyways, I did this with a lot of help from the guide, really, unfortunately. Because I really crammed to get all this done. Tried to study up a little bit, but I don't know how effective my studies were. Anyways, I know I'll understand it before the test, but not too proud of this homework. Yeah. I think I took on too much this semester, I guess. I thought this class I'm retaking, I thought it'd be easier, but I obviously don't remember these sections very well compared to the first, couple chapters. So, but hope to do well on the next test as well.